Greetings, so welcome back to learning. I hope you're all doing well, and as you know, we are going to continue learning from home from now on until further notice, actually. And I thought that would be a good idea that we start with a quick review of what we have learned before March break. As you remember, we were working on Unit 7, which was about investments and ordinary annuities. So I have organized actually this review in 3 different days. So on the first day, we're going to talk about future value, second day, present value, and then another summary on the third day. So here goes the first day. We're going to talk about compound interest and ordinary annuity to start with. And the formula for compound interest, we're talking about future value, is A equals P 1 plus I to the power of N. So when we say future value, actually, we mean the accumulated amount of money A. So, and in a formula, this is indicated by letter A, right? So it means the same thing. So accumulated amount of money or future value means the same thing. Here we go. This one here and this one here. All right. The next formula that we are going to mention here is ordinary annuity. So remember that here we had this big long formula, the big fraction. So that would be A equals R, big square brackets, 1 plus I to the power of N minus 1, and that divided by I. Okay, so we're going to talk a bit about these two formulas. So we have learned 2 types of investments. A one-time investment and a regular payment investment. So just a quick review again. So what is a one-time investment? A one-time investment is when you invest a fixed amount of money one time only. So we're going to write this down, and I strongly suggest that, if possible, you print out this blank copy and write as you watch the video. So again, we said that this is when you invest a fixed amount of money which is also known as the principal amount okay, one time only. And this one time is at the very beginning of the investment. So at the beginning of the investment. Okay. Now, a regular payment investment is when you invest the same fixed amount of money every fixed period of time, and you make this investment regularly, and that's where the name regular payment investment comes from. So we're going to write the definition as well. So we're going to say regular payment investment is when you invest the same fixed amount of money amount of money, if you remember, is indicated by letter R, so stands for regular payments, every fixed period of time. obviously it's a payment that is made regularly. Okay, so how do we calculate the interest earned? So if we are in a one-time investment, which is called the compound interest formula, we find the interest earned as the difference between the amount accumulated take away the investment made. So, and it's kind of common sense as well, but we do have a formula for each type of investment if we want to use one. And we have, for a compound interest investment, we have the formula I equals A, which is accumulated amount of money, minus principal, which is the principal you invest once. And in an ordinary annuity, it will be the difference between the amount of money accumulated, take away the amount of money invested. Now remember that in an ordinary annuity, the total amount that you invest would be the total number of regular payments multiplied by the regular payments. So that would be, this would be the formula for the interest earned in a regular, in an ordinary annuity. Okay, so now let's take a look at a couple of examples where we use these formulas. So we have two word problems that we're going to look at, and the first one, and before we start, so I just want to mention one more time, remember that whenever we solve these problems, first time you read it, you just read it in general to get an idea of what the problem is about. So here is the story of this question. Malachi had saved all his birthday money in a piggy bank, a total of $4,250. Well, I should say, good job. Oops, that was not supposed to happen. And today he decides to invest them in a compound interest account. And TD Bank has offered him the highest interest rate of 1.7%. Seems that Malachi has been shopping around. So 1.7% is compounded monthly. And Malachi decides to let the money grow for 4 years until he graduates from college. Now I'm going to read the problem a second time. Now my focus will be on articulating all these numbers given and trying to interpret the meaning of each and every one of them. So it seems that this would be the amount of money he can invest, $4,250. So we're going to call this, as you've probably guessed, the principal amount, $4,250. And he is investing this in a investment that earns 1.7%. Remember, the interest rate you're given is always your annual interest rate. So that is indicated by letter R. So we're going to write R equals 1.7%. 1.7% means 1.7 per 100. And the decimal form of it is 0.017. Now this amount of money is growing every compounding period, and according to this question, it's compounded, the compounding frequency is monthly. So that will change our interest rate, annual interest rate. So since we have monthly compounding frequency, then I would equal 0.017 divided by 12. And why by 12? Because there are 12 months in a year. Now, Malachi decides to let the money grow for 4 more years. So that means that the time of accumulation is 4 years. And with the money compounding monthly, that means that there will be 12 times 4 years, or 48 compounding periods in total. All right, and we're gonna say that now we have all the numbers in the right places here, and we are going to start solving. It's a one-time investment, so I'm gonna make a note of this right here. It's a one-time investment, so that means that it's compounded interest. And the formula that we're going to use as a result would be A equals P 1 plus I to the power of N. And substitute everything. We're going to get principal 4,250, 1 plus 0.017 divided by 12 to the power of 48 compounding periods. And I did all my calculations actually, and I'm going to show you something really cool that I just found out online. It was this free app with a calculator, and it's a TI calculator, and I'm not going to rate you now. And it is actually, oops, I shouldn't have done that. And it was a free app. I like that. And I'm going to do the calculations now. We have 4,250, open brackets, 1 plus 0.017 divided by 12, close brackets, to the power of 48. There we go. And we find out that $4,548.83 was what Malachi had accumulated. So let's go back to our video, which is right here. And we're going to say that the amount accumulated is $4,548.83. So question B here is asking to find the, let me undo this. So it's asking us to find the interest earned, and we're going to do that now. So the interest earned, since we are in a compound interest, is accumulated amount of money minus the principal. So that would equal $4,548.83. Take away 4,250. So the interest earned is $298.83. Okay, so here are our answers. Okay, let me choose a different color here. So here are our answers. We have accumulated amount of money equals 4,548, and the interest earned is $298.83. Okay, next example. We have Hussein this time investing in an ordinary annuity at TD Bank. So I'm very happy they're being very straightforward here, saying that this is an ordinary annuity. So we're going to use an ordinary annuity formula. He has deposited $950 every 3 months, and that happened for 10 years in a row. And the financial advisor offered him the best interest rate that the bank could offer, and that was 2.5% per year. So we have to find out how much Hussein would be able to accumulate by the end of the investment. So let's get to work, and let's write down the numbers given. So regular deposits would be $950. That's the amount he's depositing regularly. And he's doing this every 3 months. So that will be the compounding frequency. So with the compounding frequency every 3 months means that that would be quarterly. Okay, beautiful writing here. And the investment has lasted 10 years, so time of 10 years with a frequency every 3 months. That means quarterly, means that he will make deposits 4 times a year, so every quarter of the year for 10 years. So in total he will make 40 deposits. And he is earning an interest of 2.5%. So again, this is the annual interest rate. 2.5% means 2.5 per 100. The decimal form of it, 0.025. And since the frequency is every quarter of the year, then the interest rate per compounding period is 0.025, that divided by 4. So we're going to find the accumulated amount of money using the ordinary annuity formula as the problem suggested. Okay, and here goes the formula. A equals, long line for our long fraction. So R 1 plus I to the power of n minus 1, and that divided by I. So here we go again. We have A equals, the value of R is 950. And then 1 plus 0.025 over 4 to the power of 40. Take away 1 divided by 0.025 divided by 4. Now remember, we can calculate this in one step. All we have to remember is honor the brackets as we type the expression in the calculator. So few things that we want to remember in here is that we are going to type 950 brackets and then brackets again. Type the expression as is, brackets, more brackets, and the denominator must be in brackets as well. So I'm going to demonstrate this in the calculator. We've gone over it in class as well, and I think you're pretty good at this. So here we go again. We have 950, and then I go brackets, and then I go brackets again. 1 plus 0.025 divided by 4, close brackets, power 40 minus 1, close brackets again. Oopsie. So let me just delete this last thing here. Okay, so I would just clear this. There we go. So sorry, I'm going to type this one more time. So 950, I got too focused on my typing here. I forgot to see where the numbers were going. This is sort of a new thing for me too. Plus 0.025 divided by 4, close brackets, and that will be to the power of 40. And then we minus a 1, close brackets, divide. Now your denominator must be in brackets as well, so we go 0.025 divided by 4 again, and press enter. And we're going to get the amount of money that Hussein will be able to accumulate in 10 years. So let us go back to our video. So by the end of the investment, Hussein would have accumulated $43,000, and then 20.08 cents here. So way to go. That's the amount of money accumulated. All right, so what is the interest he earned? Well, this is how much he accumulated, right? And the interest is the amount accumulated, take away the money he invested. So the interest equals the amount accumulated minus the amount of money that he had invested. Now remember that this will indicate how much Hussein had invested. So regular payments times the number of times that he made those regular payments. So that would be equal to $43,020.08. Take away 40 payments of $950 each. So the interest earned in this case would be $5,020.08. That's the interest earned. Okay, let's box this up. That's the final amount earned. And this was today's lesson. I encourage you to do questions number 6B on page 416 and number 10 on page 417. Try on your own.